In this video, you will see the progression of how your student learns in 4th and 5th grade. Notice we've started this video with some information on learning our fast facts. Again, this is very important in your child's success with multiplication. This video also will move your child through the understanding of multiplication through a model to having an efficient strategy, such as partial products or the standard algorithm.
This is the multiplication progression, a chart designed to show how a student progresses in their multiplication thinking from 3rd to 5th grade. In video 1, we talked about 3rd grade modeling of multiplication. That's what you see on the left. In the middle, these are the models and strategies students use in 4th and 5th grade to solve multiplication problems. We're now going to show you some of those models. Later on in this video, you will see that right-hand side of the progression, what students use at the end of 5th grade as their strategy for solving multiplication. This is a good time to talk about multiplication facts. Any student that does not know all of the facts from 0 to 12 is at a disadvantage in math class. And any 5th grader that doesn't know all of the multiplication facts will struggle in 5th grade mathematics. This tool is the multiplication matrix, a tool that we use with students to show them that once we look at all of the facts that we have strategies for, there won't be a lot of hard ones left to learn. The way this tool works is if you look at the numbers in orange down the left and across the top, these are the two sets of numbers that we're going to be multiplying by. The smallest fact is 1 times 1. And if you draw your fingers over and across, you get to that first box in the upper left corner that is the answer to 1 times 1, or 1. The largest fact on here is 12 times 12. If you put your fingers on the two 12s and slide your fingers across the matrix and down the matrix, you will come together at the number 144 in the bottom right corner. That's the answer to 12 times 12. Any fact between 1 times 1 and 12 times 12 is on this matrix. Beginning in 3rd grade, we talk to students about the importance of learning the multiplication facts. We use this tool, the multiplication matrix, to help show them that there actually aren't a lot of facts they need to memorize. Students often know anything times 0, which is not on this chart, is 0. That's a quick one to learn. They also learn that anything times 1 is just the other number. Once they know times 1, they can talk about times 10, being that it is the other number moved over a place value. So instead of 3 times 1 is 3, 3 times 10 is 30. After talking about times 10, we talk about times 5. Times 5 is just half of times 10. When a student is presented with 8 times 5, we tell them to do 10 times 8, which is 80. And then cut that answer in half. Half of 80 is 40, which is the answer to 8 times 5. Next, we talk to students about times 2, which students will call doubling, because all you're doing is taking the other number and adding it twice. So 8 times 2 becomes 8 plus 8, or 8 doubled, which is 16. Students often talk about times 4 as double the double, which is if you had 9 times 4, you would do 9 plus 9, which is 18, and then add another group of 18. That's doubling and then doubling again, hence double the doubles. Finally, another easy fact family is times 11, because we know that 11 can be broken up into 10 and 1. So 8 times 11 is just 8 times 10, and 8 times 1, or 88, put together. Those facts are easy up until we get to 10 times 11. After that, those last couple, including 11 times 11 and 11 times 12, are harder for students to learn. This line, this black line cutting diagonal through the matrix, is here to show kids that the two sides are a mirror image. If you can find 4 times 8 on one side, you can also find 8 times 4 on the other side, which means you don't need to learn both of those facts as if they're separate. It means we only have half as many of the white facts, the facts that we haven't found a strategy for yet, to learn. In all honesty, we actually have strategies for all the rest of these facts, but we teach them individually as kids learn them.
It is important to help your child learn all of these math facts. Flashcards are a good tool. First, they're actually very inexpensive. You can find them at the dollar store or Walmart or Staples for usually under a few dollars. Flashcards are a great tool. You can use them and make piles so that you can then see a pile of what your child knows versus what your child doesn't know, and then continually practicing those that your child doesn't know. Using a timer can help to motivate your child. For instance, you could pick 10 cards, practice those 10 cards, and see how long it takes them to then complete those 10 cards. There's also some great computer games. For instance, there's a website called multiplication.com that you can use to find some very fun interactive multiplication games. If you'd like some additional tools of the non-technology variety, please attend a multiplication parent night as we have some additional games. Our last message we want you to hear about the math facts is that your child must know these multiplication math facts. Even when you think they've learned them and they know all of them, keep studying, as we find that after a summer or maybe even just after a few weeks of not studying, students actually begin to forget them or just lose their speed. So please keep studying. Now we're going to show you how we help students solve larger multiplication problems. In this story problem, Maggie made 4 batches of cookies, and in each batch of cookies, there was 13 actual cookies per batch. We want to figure out how many cookies did she make altogether. What we do to help students understand this is we use what we call these linear pieces. As you can see on the left-hand side of the screen, those linear pieces show the dimensions of the multiplication equation. So those actually say that there's the 4 batches of cookies. We then show that we're multiplying by the 13 cookies per batch. Notice that we've already allowed for using larger multiplication by that long linear piece, which actually represents 10. Once we use those long linear pieces that represent 10, we can multiply by any numbers. In this case, 4 times 10 is actually 40. And kids can actually see that 4 base 10 pieces will fit within that area. We then multiply the 4 times 3 and get 12. In this scenario, we see that 4 times 13 is actually 4 times 10, which is 40, and 4 times 3, which is 12. To get the final answer of how many cookies we've baked, we simply have to add 40 plus 12, and that gets us our 52. In the previous slide, we showed you how we solve a 2-digit by 1-digit problem using the linear pieces in base 10 blocks. As you can imagine, that's not a strategy that's going to work forever. We need to move kids from that conceptual understanding of what multiplication looks like to a better strategy, a more efficient strategy that will always work for them. The next move that we make is using this base 10 grid paper that you see. This paper allows us to still use the same conceptual understanding of multiplication, use those ideas of the base 10 linear pieces, but we do it and can solve 2-digit by 2-digit numbers. In this scenario, we're trying to solve 32 times 16. You can see that we can place that 30 right up on top of the base 10 grid paper. And instead of calling that a 10 and a 10 and a 10, we can just show that as 30. We then add 2 more and know that that's our dimension of 32. We know we're multiplying that by 16. 16 is actually a 10 with 6 more. This actually shows the outline for our problem, 32 times 16. And now our job in actually solving the multiplication problem is finding the area within. To do that, we actually looked for chunks that we can solve easily. In this case, we know that 10 times 30 is 300. And we can see that when we fill in that area, there's actually 300 blocks, because each 10 by 10 is 100. So we've started with 30 times 10 is 300. We then can solve 30 times 6. Again, we can see in the base 10 pieces that 30 times 6 equals 180. Our next step is to do 2 times 10, which we can see is 20. And lastly, we have that smallest piece, which is our 2 times 6, which equals 12. To find the total area, we now know that we just need to add those 4 partial products up, getting that final answer of 512. Obviously, we don't want a kid to need to actually count each of those little area pieces in the middle, but if we were, we would find that there were actually 512 pieces within the area. So 32 times 16 equals 500.
Let's try another double-digit times double-digit multiplication problem using that same grid paper as we did in the previous slide. Again, this grid paper is not where we want your child to be when they are proficient at solving multiplication problems. This is just a stepping stone to getting to more efficient algorithm. Let's solve 27 times 19. Again, our first step is to lay out that 27. 20 plus 7 along the top. The other dimension, 19, we're going to break into 10 plus 9. Looking for the largest chunks that we can fill into our area, immediately we can see 10 times 20, which is 200. 2 groups of 100. Another big chunk is 9 times 20, or 180. Next, we can do 10 times 7, 70. And we're left with one last chunk to make it into a rectangle. 9 times 7, 63. To get to that total area, we need to add up each one of those chunks for a total of 513. This brings us back to the multiplication progression. We've now seen how 3rd graders model multiplication, 4th graders model multiplication, and in the beginning of 5th grade, how those students model multiplication. We're now going to show you the efficient strategies that we hope students will leave 5th grade being able to do. Any of the strategies in this last column, we're okay with students leaving 5th grade using as their primary strategy to solve any multiplication problem. We're going to show you how these strategies connect to the models, the area model that we've shown you earlier. In the previous slides, we've shown you how students use pieces to solve multiplication problems, grid paper to solve multiplication problems, but now we're moving kids away. We want kids to be using more efficient strategies, and one step beyond the grid paper is to give them a blank piece of paper and have them solve it without all those squares. We call that an open area model. Open because you can't actually see all of the little squares that make up the array. Kids know that when solving 58 times 45, the shape of it is going to be a rectangle. They often already make the divisions inside of it to show the number in the tens place and the number in the ones place for both divisions. And just like before, that left us with 4 multiplication problems. Kids will write that 50 plus 8 across the top dimension and the 40 plus 5 along the side dimension. The biggest area, like in the previous problems we've done, is that the tens place multiplied together. So we'll do 40 times 50, and know that's 2,000. Notice how there aren't 2,000 squares that we can see in there, but we ask you and students to imagine, to know that and trust they really are there. Then we'll do 50 times 5 and get 250. 40 times 8 and get 320. And then that last little square, 5 times 8, which has 40 squares in it. We have each of those partial products filling in that array. To get to the total, we add them all up. Often students will put together that 2,000 and that 320 together in one step because it's easy addition. They'll do the same thing for the 250 and the 40 to get 290. Now what they have to do is add up those two parts to get 2,610, or the total number of little squares, the total area of this rectangle.
The area model is a great model for conceptual understanding, but it is not an efficient model, and we do not want the area model as your child's final multiplication strategy. On this slide, we are going to show you how the area model and the partial product strategy that many 4th and 5th graders use as their multiplication strategy are connected. We will also show you how we move from the area model to the partial product strategy. This slide goes back and forth so you can see how these strategies are connected. We'll start with the area model. As we've learned, we labeled with 34 times 81, we label one side 30 plus 4 and our top side 80 plus 1, breaking it into that area model. We start with that biggest chunk of 30 times 80, and we know that 30 times 80 is 2,400. If we look over at the partial products, we can see that 30 times 80, that 30 in the 34, and that 80 in the 81. That is the same equation we've just solved in our area model. So 30 times 80 is 2,400, and we slide that over there. You'll notice that we're showing you both the area model and the partial products model, but when your students will be solving these problems, they will only use the partial products model and will not actually draw the area model. So if we look to our area model, we look to the next equation. We have that 80 times 4. 80 times 4 is 320. Again, if we look at the partial products equation, we can see that 80 and 81, and that 4, 80 times 4, is 320. Back to our area model, we have our 30 times 1, and in our partial products equation, that 30 in the 34 times that 1 is equal to 30. And then our last chunk of that area model is that 4 times 1, and in our partial products equation, we see that 4 in 34 and that 1 in 81. 4 times 1 is 4. The last thing we have to do is add up all of the products we've just found from those 4 equations, and we get 2,754.
On the last slide, we showed you the connection between the area model and partial products. In this slide, we'd like to show you the connection between the area model and the standard algorithm. The standard algorithm is most likely how you learned how to multiply in school, as it's certainly the way that I learned. We want you to understand that both the algorithm and the partial product strategy that we told you on the previous slide are acceptable, efficient strategies for your child to use. In the standard algorithm, we start by multiplying 8 times 5, which equals 40. We place the 0 in the ones place, and we carry the 4 into the tens place. In the area model, we know also that 8 times 5 equals 40, and you can see that in the the right-hand corner on the bottom of the area model. Next, in the standard algorithm, we multiply 5 times 5, I was always told that you actually just said 5 times 5, but I now know that that's actually 5 times 50, or 5 times 5 tens. I know that 5 times 50 is 250, but then I actually have to add that 40 in that I've placed up on the top, and I know that that answer is 290. Over in the area model, I know that 50 times 5 equals 250, and I add the 250 and the 40 along the bottom, and I can see that that's the same answer as that first line on the algorithm. Next on the algorithm, I place that 0. I never understood as a child why that 0 was being placed. Again, I now understand that I'm multiplying by 10, so the 0 is actually just a placeholder. In the algorithm, I then multiply 8 times 4 tens, or 8 times 40, which is 320. I place the 2 in the tens place and carry that 300s. Over in the area model, I also can see that 8 times 40 is 320. Next, in the algorithm, I do that 5 times 4. Again, I was taught that I just say 5 times 4 is 20, and add that 3 up top, and write the 23. I now see that that's actually 50 times 40, which is 2,000, and add the 300s, which shows me 2,320. Over in the area model, you can see that that 50 times 40 is 2,000. Again, the area model, the top part, shows that 2,000 plus the 320, which is exactly what we see on the bottom of the algorithm. To get the final answer, all I need to do is add up in the algorithm those two numbers. Again, we want to remind you that if your child uses the algorithm as their efficient strategy, that is acceptable, as is also the partial products strategy.
We have reached the end of the presentation. There are various ways you can help your child at home with multiplication. One way is to help your child learn the multiplication facts from 0 times 0 to 12 times 12, and then continue practicing the facts after they have memorized them. You can also allow your child to use the strategies that they learned in school, and encourage that your child completes all homework, providing a quiet and comfortable space to get this done. Also, resist the temptation to teach your child how you learn to do multiplication. Know that if you are going to use that to help your child complete homework, try to make connections between the way you learned multiplication and the way he or she is learning multiplication. Thank you for taking the time to watch this presentation. If you have any further questions or comments, you're welcome to call us at the Math Lab. The number at the school is 476-6541. You can ask for the Math Lab, and we'd be happy to talk to you and sit down and answer any of your questions you might have. If you have further questions, you can come to one of our parent nights and ask the questions then, when we'll be going through the same presentation